Hello everyone. In this session, we shall discuss section number 10.5, circle through 3 points. Now, before looking at circles passing through 3 points, let's recollect what we had learned in the earlier classes. Now, if I give you 1 point, then how many straight lines can you draw passing through this point? We have already seen this, that you can draw infinitely many lines which are passing through this point. Okay, and you can keep doing it. If I give you two distinct points, then you know that you can draw a unique line passing through it. That means only one line you will be able to draw. Right? Now, if I give you 3 points which are collinear, then you can draw one line which is passing through all three of them. And if they are non-collinear, then it is not possible for you to draw one line which will pass through all three. So this was regarding the line. Now, if I give you 1 point, then how many circles can you draw passing through this point? Right? You can keep drawing circles which will pass through this point. Okay, you can draw infinitely many circles basically which are passing through that point. And you can keep doing this. Again, if I give you two distinct points, you can draw infinitely many circles which will pass through these 2 points. Okay. Yeah, I will take the points little further so that slightly easier for me to draw. So let's say this is my first point and this is my second point. Then again I can keep drawing. 1 second. Yeah, this is one. I think drawing with the free hand is slightly easier, so let me do that. So I'll mark this as point A, and this, let's say this is point B. Then you can have a circle here which will pass through these 2 points, right? You can draw a slightly different circle here which will pass through these 2 points again. So again you can draw infinitely many points which are passing through these 2 points A and B. Right? Now the next question that comes is, if I give you three different circles, three distinct points, how many circles you can draw passing through them? Now if the 3 points are collinear, then it is not possible for you to draw one circle which will pass through them. Because if you draw a circle passing through the first two, then the 1 point will be on the exterior of the circle. And in the second scenario, if you draw a circle passing through the first and the third one, then the second point will be in the interior of the circle. So in this case, it is not possible. But if I give you three distinct points, then there is a unique way to construct a circle which will pass through all of them. And there is one and only one circle which will pass through these three non-collinear points. Okay, so that I'll demonstrate in the coming theorem. Theorem 10.5. There is one and only one circle passing through three given non-collinear points. This means if I give you three non-collinear points which are not on a line, then you can draw one and only one circle, a unique circle which will pass through all three of them. Okay. So now what I'll do is I'll demonstrate the procedure on how to construct the circle passing through the three given points. So as you can see here, I have 3 points A, B and C which are non-collinear. So first step one is I will join AB and I'll join BC. Next, I'm planning to draw a perpendicular bisector for the line segment AB. So I will keep my compass on the point A and draw an arc on either side of the line segment. Next, I'll keep my compass on the point B and I'll draw arcs on either sides of the line segment AB. Then I will join the intersection of these arcs, which will give me the perpendicular bisector of the line segment AB. I will repeat the same process for the line segment BC. And then I will draw the perpendicular bisector for BC. You observe that the perpendicular bisectors of AB and BC meet, mark this point as O. And this point O will be the center of the circle. Now if you observe here, the distance OA, OB and OC are all the same. So taking OA as a radius, I will draw a circle taking O as the center. And that produces a circle passing through the 3 points A, B and C. Now this is the unique circle which will pass through A, B and C. It is not possible for me to draw another circle which will pass through the 3 points A, B and C. Next, so this theorem is demonstrated. Remark 1. If ABC is a triangle, then there is a unique circle passing through the vertices A, B and C. This is conclusion from the previous theorem. This circle is called circumcircle of the triangle ABC. Its center and radius are called circumcenter and circumradius respectively. Look at the next example. Given an arc of a circle, complete the circle. So one arc of a circle will be given to you. Using this, you have to draw the entire circle. Okay, so again I will demonstrate this with the help of pictures. Let's say we are given an arc PQ. So I have to draw the circle in such a way that PQ is an arc of that circle. Basically, given an arc, we have to complete the circle. So first we will mark one point R on the arc PQ. Next, you join PR and QR using line segment. Now we will follow the same process as we had seen in the demonstration of the last year. We next draw the perpendicular bisector for PR and perpendicular bisector for QR. These two perpendicular bisectors meet at the point O. So taking OP as a radius, you can complete the circle now. And that is the required circle such that PQ is an arc of that circle. So this way, given an arc of a circle, you can complete the circle. Thank you.